everyone. So in today's video, we're going to wrap up Module 2 and we're going to discuss different types of chemical reactions. So one type of chemical reaction is a combustion reaction. And if you've ever lit a candle before, that is a combustion reaction. So typically if something involves oxygen, we consider it a combustion reaction. But let's talk about these types of chemical reactions in more detail. All right, so there are 5 types of chemical reactions. Again, one of those is the combustion reaction, but the other 4 are combination, decomposition, single replacement, and double replacement. So we're going to go through each type, and I'll also show you examples of each type of reaction. So the first type of reaction is a combination reaction. So really we're just combining 2 or more elements and they're forming a single product, which is a compound. So again, you have 2 or more elements in the reactants and 1 product. So one example is if you combine sulfur and oxygen, and that will produce sulfur dioxide. Now, you could also have 2 or more simple compounds that are combining to form 1 product. So, as an example down below, we have a compound, SO3, reacting with H2O, water, and then that produces H2SO4, which is sulfuric acid. And then there's a couple of other examples listed here. You'll also notice that some of these examples have coefficients, which are balancing the chemical equations. So let's look at an example of a combination reaction. So this is a reaction between bromine and aluminum. So Br2 plus Al, and then that ends up forming Al2Br3, and then we have to balance our reaction, so we need 2 aluminums on each side. And let's see, we need 6 bromines on each side. So 3, 2. Oh, so now we need to change this to a 4. All right, so that's probably a more difficult balancing equation. But let's watch this video. It's a really cool reaction. So let's go to YouTube. There we go.
To start, bromine is added to a test tube. This is bromine that was made in a previous video and it was stored in my homemade ampules. I show here that it can be easily opened by breaking it open with a pair of pliers. Then, aluminum foil is added to the test tube. Due to the protective oxide layer on the outside of the aluminum, it takes a little while to react. The aluminum reacts violently with the bromine to form aluminum bromide. When slowed down to about 1/4 the speed.
So that was a really cool reaction, and if you want to watch the rest of that video, I have it posted on Canvas under Modules Week 4. All right, so again, that's an example of a combination reaction. Now, the next type of reaction is a decomposition reaction. So in this type of reaction, we start with just 1 reactant, so 1 substance, and it's going to split into 2 or more simpler substances. So we actually saw an example of this when we were balancing equations. There was H2O, water, and it was splitting up into H2 and O2. And then we balanced it, and we found that the coefficients were 2, 2, and 1. So we started with a very simple substance, and it split into simpler substances. So again, with decomposition reactions, you start with one reactant, and then you end up with two or more products. So some reactions are shown below. So we have a decomposition reaction where mercury oxide splits into pure mercury and pure oxygen. And I also have an example of water splitting, which we just saw. Let's go to YouTube. We'll wait for it to load.
To separate the atoms that make up water, scientists need energy to break the bonds that hold the atoms together. To do this, they run an electric current through the water. Bubbles form in the tubes where the current makes contact with the water. These bubbles rise to the top of the tubes and fill them with clear gas. As the bubbles rise, they are captured to see what they are made of. One tube is filled up with twice as much gas as the other tube. Once the gas is collected, scientists test the bubbles' properties to determine what elements are present in the gases. One gas is determined to have a low density and will glow brightly in the presence of fire. Scientists can identify this gas as oxygen based on these properties. The other gas produced has twice as much volume as the first. This clear gas is determined to have an even lower density and reacts explosively when brought near a flame. These properties identify the gas as hydrogen. It is noted that no matter how many times the experiment is done, the results are always the same, and there is always twice as much hydrogen as there is oxygen.
All right, so again, in this reaction, they used an electric current in order to turn water into pure hydrogen gas and pure oxygen gas. So we could even put in the states there as well. And then we'll also balance it. Now, this does take quite a bit of energy to occur. So that's why they had to use an electric current in order to split water. But additionally, we could also see that there was 2 times as much hydrogen as oxygen. And we can see that in our balanced equation as well. There's always 2 times the amount of hydrogen gas in the products compared to oxygen. All right. So now for a single replacement reaction. So in this type of reaction, we have one element and then also a compound, and they're reacting together, and that one element is going to replace an element from the compound. So let's say we have a generic element A and a compound BC. A and B are actually going to switch places, so we'll end up with a product AC and B. So that's why it's called a single replacement reaction. There's just one element replacing another element. Now there are multiple types of single replacement reaction, or I guess examples of single replacement reactions. So for instance, if you have pure zinc and you place it in an acid like hydrochloric acid, HCl, that will produce a compound called zinc chloride and hydrogen gas. So in this reaction, zinc replaced hydrogen in the acid. So zinc now is bonded to chlorine, and then the other product is just pure hydrogen. So let's look at that in a little more detail. So up above, we have a beaker filled with hydrochloric acid, and that has been diluted, so it would actually be called aqueous. So in our reaction equation, we would write HCl aqueous because it's been diluted in water. Now, if we place a piece of zinc in that acid, what we see are some bubbles forming. So in this picture on the right, you can see some bubbles forming there. And remember that the formation of bubbles indicates that a chemical reaction is occurring. Now, in this case, the bubbles are hydrogen gas. And then there's also another product called zinc chloride, and that is going to be now dissolved in the water, so it's kind of replacing the HCl, the hydrochloric acid. So we would call that aqueous as well. All right, so again, zinc is replacing hydrogen, and hydrogen is leaving as a gas, and then the zinc is kind of teaming up with the chlorine to become zinc chloride. All right, so let's look at another example of a single replacement reaction. So in this reaction, copper is going to react with something called silver nitrate, AgNO3. And copper is going to switch places with silver. So we end up with pure silver at the end and copper nitrate. Okay, so let's watch this video. All right, so he or she, I don't know, is adding the silver nitrate. And you can already see a color change occurring on the penny. Yeah, you can definitely see a color change there. So that's the copper replacing the silver, and now there are silver deposits on the copper. So we're ending up with pure silver. Now again, this can only occur with pure copper, so you would need a penny from before 1982. Okay, yeah, you can definitely see the silver there. All right, and again, if you want to watch the rest of that video, it is on Canvas. All right, now the next type of reaction is a double replacement reaction. So this is kind of similar to the single replacement reaction, except this time everything is switching places. So let's say you have, oh, I have a mark here from a previous, there we go. Oh, I can't erase it apparently. So in this reaction, let's say we have a compound AB and another compound CD. Now, what's going to happen is A and C are going to change places. So we'll end up with AD as one of our products and BC as our other product. So one example shown below, we have silver nitrate and sodium chloride, so AgNO3 and NaCl. And the metal elements are going to change places. So silver is going to switch places with sodium. So now silver will team up with chlorine, and sodium will team up with NO3. And those will be our two products. Okay, so let's watch an example of a double replacement reaction. Now, this reaction is also called a precipitation reaction. And the reason for that is initially AgNO3 is aqueous, so that means it's dissolved in water. And NaCl is also aqueous, so it's also dissolved in water. But when they mix, we end up with AgCl, which is actually a solid, and that's our precipitate. And then NaNO3 is just going to be aqueous, so just dissolved in the water. So let's watch what happens when that occurs. All right, so we have two clear liquids to start, or aqueous solutions. And then we're going to add one to the other, and you can see a precipitate forming, and that's the AgCl, or silver chloride. And then it's going to kind of sink to the bottom. All right. And we'll see some more examples of precipitation reactions or double replacement reactions in the future. Now, finally, we have combustion reactions. So in a combustion reaction, we have a carbon-containing compound, and that's going to burn an oxygen gas to form carbon dioxide, CO2, and water, H2O. Now, additionally, energy will be released in the form of heat. So, looking at this reaction here, we have CH4, which is methane gas, and that will react with oxygen to produce carbon dioxide and H2O gas, as well as energy. Now, another example, C3H8 is propane. So if you've ever used propane before, it reacts with oxygen to produce CO2, H2O, and energy. And of course, we have to balance these reactions, so you'll notice different coefficients there. But again, the general idea here is that you always have a carbon-containing compound, like methane or propane. You always have oxygen, so O2, and then you'll always end up with CO2 and H2O, as well as energy. Now, there's a couple of other examples where maybe you have a compound reacting with oxygen that doesn't combust necessarily, or you might see a combustion reaction that doesn't have a carbon-containing compound necessarily. There's, some exceptions, but for the most part, this is how combustion reactions look. Now, in your textbook, there's a nice little summary table, table 7.3. So if you want to make flashcards for these different types of reactions, I recommend, for instance, if we look at the combination reaction type here, you could write combination on one side of your flashcard, and then on the other side, you could write A plus B becomes AB, which is just our generic reaction symbols. So that could help you memorize these different types of reactions. Okay, so let's do a quick learning check. So down below, there's a list of 4 different types of reactions, and you're going to identify them as either a combination, a decomposition, combustion, single replacement, or double replacement reaction. So if you want to try this on your own first, you can pause the video, and then we'll go over it together. Okay, so let's start with A. We have solid aluminum reacting with H2SO4, which is sulfuric acid. But don't worry about naming just yet. We'll do that later. And those two are reacting to produce Al2SO43 and 3H2, so hydrogen gas. So what type of reaction does this most resemble? So if you were stumped on this one, notice that aluminum is ending up in a compound, whereas it started off by itself. And then hydrogen started out in a compound and then ended up by itself. So it looks like aluminum and hydrogen changed places. So what type of reaction is this? A single replacement reaction. So we started out with just a single element and then a compound, and then the element replaced an element in the compound. So that is a single replacement reaction. What about B? We have Na2SO4, which is called sodium sulfate, and AgNO3, which is silver nitrate, and they're reacting to produce Ag2SO4, which is silver sulfate, and NaNO3, which is sodium nitrate. What does this most resemble? So if this one had you stumped, this sodium here was originally attached to this SO4, but then in the products, silver is attached to SO4. And then originally silver was attached to NO3, but in the products, sodium is attached to NO3. So it looks like sodium and silver switched places. So what would this be? Double replacement. So we had two compounds to start, and we ended up with two different compounds in the products. So that's double replacement. What about C? We have nitrogen reacting with oxygen to give us a compound. Hopefully this one was a little bit easier. This is just a combination reaction. So we're just combining two substances to make one product. And then what about D? We have C2H4 plus oxygen, and we're producing CO2 and H2O and energy. So that's a combustion reaction. So we see our carbon-containing compound, we see oxygen, and then we have our typical products for a combustion reaction: CO2, H2O, and energy. All right. So here are these solutions if you need those later. Let's do one more set of reactions. So let's go over these together. So reaction A, we have barium reacting with nitrogen to produce a compound. What would that be? A combination reaction. What about B? We have silver, Ag, reacting with hydrosulfuric acid, H2S, and that's producing two products where we have Ag2S and hydrogen. So this one is a single replacement reaction. So we have silver by itself initially, and then it ends up in a compound in the products. And then hydrogen is initially in a compound, but ends up by itself at the end. So Ag and H are switching places. Now what about C? We have C2H6 reacting with oxygen to produce CO2, H2O, and energy. So that one should be easy. That is a combustion reaction. What about D? We have PbCl2 plus K2SO4, and we end up with KCl and PbSO4. So in this one, this is a double replacement reaction. So we start with two compounds and we end up with two different compounds at the end. So lead is initially paired with chlorine, but in the products it's paired with SO4. And then potassium is originally paired with SO4, but in the products it's paired with Cl. So these two are switching places. And then what about our last reaction? K2CO3 is producing K2O and CO2. So this is a decomposition reaction. And a really easy way to tell that you have a decomposition reaction is that you only have one reactant and you have two or more products. So if you only see one reactant, then that is probably a decomposition reaction. Okay, and here are the solutions. And that is the end of Module 2. So we're going to start Module 3 next time. So I will see you then.